Resistors are the most common component in modern electronics, but choosing the wrong type can destroy your circuit's signal integrity or cause your hardware to overheat and fail fast. If a resistor simply restricts the flow of current, why do we need so many variations? Why can't you substitute a precision metal film resistor for a wire-wound power resistor, even if their resistance value is exactly the same? Today, we are breaking down every major type of resistor on the market. We'll look at their internal material chemistry, their hidden parasitic properties, and how to select the perfect material for everything from audio filters to heavy industrial power supplies.
Part 1. Fixed carbon resistors, the hobby standards.
Let's start with the heritage choices.
Carbon composition resistors are made from a solid cylinder of graphite dust mixed with a non-conductive ceramic binding powder. While they are structurally robust and handle massive brief energy surges wonderfully, they have a major weakness. They absorb moisture from the air, causing their resistance to drift wildly over time. They also introduce significant electrical noise, making them terrible for clean audio or sensitive measurement paths. To solve this, manufacturers created carbon film resistors. By depositing a pure carbon film onto a ceramic rod and laser cutting a precise spiral groove into it to dial in the resistance, they achieved much tighter tolerances, typically around 5%, and dramatically reduced component noise. These are the classic, inexpensive axial resistors you find in standard electronic starter kits. Part 2. Precision and modern surface mount. When accuracy is critical, you graduate to metal film and metal oxide resistors. Instead of carbon, these use a vapor-deposited layer of metal alloy. These boast extreme precision, down to 1% or even 0.1% tolerances. Crucially, they possess a very low temperature coefficient. This means as your circuit heats up under load, their resistance value stays rock solid, preventing drift in analog timing or voltage divider calibration circuits. In modern commercial production hardware components, axial leads are swapped for SMD thick film and thin film chip resistors. These tiny rectangular blocks use a metal ceramic paste screen printed onto a ceramic substrate. Thin film variants offer lower noise and higher precision, while thick film chips are cheaper and ideal for general-purpose digital pull-up or pull-down links.
Part 3. Heavy-duty and inductive traps. When your circuit needs to dissipate serious power, measured in watts rather than milliwatts, you switch to wire-wound resistors. These are made by wrapping a high-resistance alloy wire, like nichrome, around an insulating fiberglass or ceramic core. However, wire-wound resistors hide a dangerous trap for beginners. Because they are literally a coiled wire, they act as an inductor at high frequencies. If you try to use a wire-wound resistor in a fast-switching power supply or radio frequency circuit, its high parasitic inductance will distort your waveforms and corrupt your signals. For high power without the inductive trap, engineers use non-inductive thick film power resistors, often clad in an aluminum chassis designed to bolt directly flat against a metal heatsink to pull destructive heat away.
Part 4. Variable resistors and protection. Finally, we reach variable resistors. These include potentiometers used for user interfaces like volume knobs, and rheostats or trim pots meant for one-time manual calibration inside a housing. There are also highly responsive, non-linear variables used for circuit safety. Thermistors shift their resistance based on temperature to prevent thermal runaway. Photoresistors, LDRs, react to ambient light levels. And varistors, VDRs, drop their internal resistance instantly during a high voltage surge, clamping dangerous voltage spikes safely away from your main processors. Understanding your resistor materials means the difference between a high-precision, low-noise circuit and a smoking failure on your test bench. Drop a comment below with which resistor material you use most in your builds. Hit that subscribe button to join our global maker community, and I'll see you on the next deep dive.